Hi guys, Miss Valdivia here. So we're going to go over density for Labflow number 3. Couple things to know about density is density is equal to the mass divided by the volume. So mass divided by volume. Okay, mass is the unit of grams, and volume is the unit of milliliters. Okay, there's 3 ways we're going to calculate density. We're going to calculate density of an unknown liquid, density of an unknown solid, and density of an unknown irregular object. So irregular shaped object. Okay, so let's start with the first one, density of the liquid. Density of liquid. Okay. So to find out the density of the liquid, we have to know what the mass is and what the volume is of our liquid. So in this case, let's say I have a container, and in my container, okay, all right, this is my empty container. And let's say my empty container weighs 20.00 grams. Okay. Now inside my container, I add 15.0 milliliters of my unknown liquid. Okay. So now I have this with some 15 milliliters of my unknown liquid. And now this right here weighs, it weighs 33 grams. It's going to weigh 33 grams actually. Okay. Let's actually change that a little bit more. No, we'll leave it. All right, it's going to weigh 33 grams. So we just figured out 2 things here. One, mass of unknown liquid. Okay. Well, that's going to be 33 minus the 20. Okay. 33 minus the 20 is going to give me 13 grams. Right. Now we also know the volume of our unknown liquid. And that is going to be the amount that we added, the 15 milliliters. So how do we calculate the density? Density is mass divided by volume. So density is mass divided by volume. So now I know that density is going to be equal to my 13 grams divided by the amount of volume I used. And I'm going to say that I was specific with this volume, that I used a volumetric pipette. Okay? And I put 15 milliliters in there. Well, now, some of you guys are probably smart and you guys could do that in your heads and say, oh, it's this much. I can't. Okay. I use a handy dandy calculator and I got a density of 0.8666667. Okay. Now, a couple things we learned from our previous chapter, chapter number 2, is that we never write everything down, right? Never write everything down from the calculator. We always go by the least precise number. And since this is multiplication and division, so division problem, we're going to go by the least amount of significant figures given to us. This one has 4 significant figures. This one has 3 significant figures, and that one has 2 significant figures. So therefore, my answer is going to be reported in 2 significant figures. So that's going to be 1, 2, right there. The number next to the 6 is a 6, so it's going to round up. So I'm going to round up. So therefore, my final answer is going to be 0.87. And you have to write down the unit. If you fail to write the unit, you actually get it wrong or incorrect because of what? you have 0.87 what? Dollars, 0.87 pencils, you know, I don't know, 0.87 of a pie. Well, in this case, our density is 0.87 grams per milliliter of the unknown liquid. Now, some of you guys go, well, what does that even do to me? Right? Well, density of liquid chart. We're going to look at the density of some liquids. A couple things I can know before I start actually looking at a list that I'm going to Google here is that the density is 0.87, which means it is less dense than water. So therefore, it's going to float above water. Okay, whatever this might be is going to float above water. So density in per milliliter. And let's go with some random chart. Okay, so according to this random chart that I'm using here, baby oil has a density of 0.82. And that is actually the closest one that I see here that matches the density that I have. So for our sake, I'm just going to write that. Oh, this must be baby oil. Okay, so it resembles baby oil. And baby oil has a density of 0.82 grams per milliliter. Okay. From that, you would calculate your percent error and figure out, well, what's my percent error? How far off am I? Okay. First one, check, done. Now let's calculate the density of an unknown solid. Let's go ahead and turn the page. All right. So before we start that, let's write down the equation. Density is equal to mass divided by volume. Okay. Mass divided by volume. You want to be able to look at this until you memorize it. The units are grams per milliliter. Okay. So this is the same as that, which is the units that are given to you right here. And I said we're going to do volume of unknown solid. Okay, so volume of an unknown solid. Okay, now this one is something similar to what we've already done in math class. Now let's pretend I have an unknown solid given to me, and it is a rectangle of some sort. Now we know that the volume of the solid is equal to length times width times height. Okay. Sorry, we're looking for the density of a solid, not the volume of a solid. We're looking for the density. But in order to find the density of a solid, you need to know, so let me write up here, density of unknown solid. Right? That's the priority. In order to find the density, we need the mass and we need the volume of our solid. The volume is equal to length times width times height. Okay. So if I take a handy dandy ruler and I measure this, and I'm not going to be that accurate, okay, I'm going to say that this is approximately 2.5 centimeters. And I'm going to say that that is approximately 4.8 centimeters. Okay, so length times width times height, and I'm just going to pretend that my height is the same as my length. Okay, so let's just say that the other side is also 2.5 centimeters. Okay, in this case, so I'm going to have 2.5 times 4.8 times 2.5. Okay, multiply all those together in my handy dandy calculator. and I get 30 centimeters cubed. Excuse me. Centimeters cubed is a volume. Therefore, centimeters cubed, and actually let me write this down for you guys. 1 centimeter cubed is equal to 1 milliliter. So the volume of this solid is going to be 30 centimeters cubed, which is the same as a milliliter. Milliliter is used for liquids, right? And centimeters are used for solids. But when it comes to our equation, we could actually plug that in because it's a 1-to-1 equality. Now, how do we get the mass? Well, let's say we took this and put this on a balance. So we had it on a balance, and the balance reads, let's say, 26.50 grams. Okay, so that's how much it weighs. Density is equal to mass divided by volume. So my mass is 26.50 grams divided by my volume of 30 centimeters cubed. Okay, put it down on my fancy dancy calculator. 26.5 divided by 30. And I get 0.883333. Okay, and so on. Well, remember we just talked about our significant figures. Okay, here we have 2, and here we have 4. So in this calculation, because it's division, we go by the least amount of significant figures, which is going to be 2. So my answer has to be reported in 2 significant figures, and that is to the hundredths place. The number next to this 8 is a 3. The 3 does not round up the 8. So therefore, my final answer is going to be 0.88 grams per centimeters cubed. That is the density of my unknown solid. And just as we did on the other one, you would look it up, compare it to a given list to figure out, well, what is your solid, right? You just compare the densities. Okay. That one is checked. So the last one is density of an unknown irregular object. Okay. So density of irregular object. So an irregular shaped object. Okay. The best example we have of this is the crown, the king's crown. So the king had a crown. Okay, and I'm going to draw a crown. Okay. And it was specially made for him. Okay, this is my crown. Okay. Now, he gave the blacksmith a specific amount of gold and said, hey, I'm going to give you this much gold for you to make me a crown. You need to use all of the gold, all of it. Okay, don't keep any, I will know. So the blacksmith makes him a beautiful crown. And the king puts it on and goes, I do not believe this to be gold. It does not weigh like gold should weigh. It weighs a lot less. But how can I prove this? The blacksmith kept saying, sir, I used all of the gold you gave me. The king was like, I do not believe you. So he hired a mathematician to figure out, did he really use the gold, all of the gold, or did he use something else instead of gold? Did he mix it? Who knows? Well, how do you do that? You can't take the length, the width, and the height to find the volume of this. You can take the mass, but how do you find the volume? Well, this is where we do this. We do something called water displacement. So when you have an irregular shaped object, you're going to use water displacement. Okay. The amount of water displaced by an object is equal to the volume of that object. Okay. So the amount of water displaced by an object is equal to the volume of that object. That is actually really, really good to know. This is like a 1-to-1 ratio, okay? So if you displace 50 milliliters of water, you have 50 milliliters of that object. That's the volume of that object, right? So going back to our crown, the king gave this guy, let's say he gave him 1 kilo of gold or 1.5 kilos of gold. Okay, he gave gold was equal to 1.5 kilograms. Right, and if you remember our metric system, you know, we could convert kilograms to grams, right, by doing a simple conversion. And in this case, you just multiply it by 10 to the third. And this is equivalent to 150,123 grams. Okay, so this is how many grams of gold we have. 1,500 grams of gold. Now let's find the volume. This is my mass equals mass of gold. Okay, this is the symbol of gold. Capital A, lowercase u. Very important that the second letter is a lowercase when writing the symbols of elements. To find the volume, let's start with water displacement. You're going to have a big enough container that's graduated, right? That means you can measure how much water using some sort of ruler. And in this container, let's say we placed, we have 1 liter of water. 1 liter is equal to 1 liter, and that's going to equal to 1,000 milliliters of water in this container. Okay, we add our crown to it. Okay, what happens? The volume of our container changes from 100 to, from 1,000 to maybe, let's say it changed to 1,800 milliliters of H2O. Okay, that's the new amount of water, and this is with the crown inside of it. Okay, my crown is in that water. What is the volume of our object? Well, you're going to take the final minus initial. So volume of your crown is equal to the volume of the final minus the volume of the initial. So 1,800 minus 1,000. The volume of my crown is equal to 800 milliliters, right? Or centimeters cubed, right? Because we just learned that they are the same. They're equal 1-to-1 ratio. Let's go ahead and find the density. Density is equal to mass divided by volume. My mass is 1,500 grams. My volume is 800 milliliters. Take our fancy dancy calculator, and we get a density of 1.875 grams per milliliter. All right, well, I'll tell you something right now. Gold has a density of approximately 19 grams per milliliter. 19 grams per milliliter. 1.875, that's closer to, let's see, let's get a chart here of metals. Metals. Let's figure out what did this blacksmith actually use instead of gold. Okay. Now, according to this chart, remember we're at 1.87. We have, okay, 1.7. Ooh, that's really close. Actually, that's the closest one in this chart. It's a 1.7. And that is magnesium. Okay, not even aluminum. Wow, magnesium metal. And he probably just brushed it off or coated it with gold. Okay, coated it with gold. So this is not gold. The density of gold is approximately 19 grams per milliliter. Okay, this is grams right here. So it's approximately 19 grams per milliliter. Therefore, the crown is not made of gold. And when we compared it to the chart, this was could be similar to magnesium. All right, you guys, I really hope these videos on calculating densities helped. We have finished here. We had the density of an unknown liquid. We had the density of an unknown solid. And we got the density of an irregular shaped object. And we calculated that density in many different ways. There we go. Excuse the mess on the rest of the table. All right, you guys, I hope you have a wonderful one and do well. If you have any questions regarding your lab, feel free to email me. Make sure you take a screenshot of whatever it is that you might have an issue with, and that way I can help you out as soon as I can. Take care.